And welcome to our presenter, Constantin Gonzalez. He's not only a Principal Field Technologist at Sun Microsystems, but also he is one of the leaders of the OpenSolaris User Group, Munich. And he will present to us how he implemented a ZFS Scrub service, which runs automatically with the help of the service management facility in Solaris.
Okay, thank you very much. So yes, and thank you for coming to this talk and resisting the urge to go to the other talk, which is very interesting. It's about OpenSolaris on ARM, so this is your last chance to leave. I will try to make this an interesting and entertaining talk so that it's worthy of the alternative. So the goals here is actually to make ZFS pool hygiene a one-click experience. So a couple of weeks ago I went to my dentist, and my dentist told me, "Oh, you need to do a better job at cleaning your teeth, or your back teeth, otherwise your teeth will decay." Well, the same is true with ZFS pools. You just can't let them sit in there. You need to take care of your ZFS pools by scrubbing them. And many people just don't know about it, or they neglect this, so I want to make this a one-click experience. And by the way, this is also an exercise in learning SMF and in learning about a couple of other things in Solaris that sort of come to your mind while implementing this stuff. So who has done something with SMF before? Good. This gives me more time to actually highlight something else. I assume that ZFS is well known already, and scripting is always easy. Who has done something with RBAC so far? Role-based access control from Reboot. Okay. And who has done something with visual panels? Okay, well, so I'm going to shift a little bit more into the visual panels part, which is actually the favorite part of this talk. And yes, another motivation is, of course, to motivate users to use SMF more often. SMF is a little bit of a stepchild. It's something like a feature of Solaris that not many people mention, but I find it very interesting, and I like using SMF for almost everything. And you'll see a couple of interesting uses here too. And of course, this is all about having a little bit of fun. I can always recommend to you to, instead of using pre-built code, try to write your own code, try to write your own scripts. It's a great learning experience. So here's the basic setup. Ulrich has talked a bit about ZFS Self Healing. This is how it works. We all know how it works. But the only thing to keep in mind is ZFS Self Healing only works if ZFS looks at the data. If you let your mirror sit there, then they will literally rot, and then data will be lost because nobody looked at the data, and ZFS didn't have the opportunity to do the above exercise of reading the wrong block, detecting that it's the wrong block, and replacing the broken block with the new one while repairing itself. So the recommendation is, of course, for every ZFS pool, you should run zpool scrub regularly, because zpool scrub will systematically go through all your data blocks. It will check all of them, and it will do everything necessary or possible to correct any errors it encounters. Of course, this works best when you have some sort of redundancy in your pool, such as mirroring or RAID-Z. But even if you don't use mirroring or RAID-Z, it's always good to know what's going on. So if you use it on your laptop, you will know whether some blocks are broken, and chances are that this is just a file that you can recover from everywhere else, maybe the OpenSolaris CD because it's a system file, or somewhere else. So it's always good to run regular scrubs. And so the rule of thumb here is for consumer level disk drives about once a month, and for enterprise level disk drives about once every 2 months is a good rule of thumb. So when we were talking about ZFS during the OpenSolaris User Group meeting, of course there came the question, can this be done automatically? So of course you can. You can set up a simple cron job and then you're done. But of course this would only be half that funny as if trying to do it the proper way. So this is all about trying to create a proper system service that will take care of your pools automatically. So this is the idea. You do a periodic cron job that runs, say, once a month. When the cron job starts, it fetches the time of the last scrub. It checks whether the pool has been scrubbed greater than one period, and one period might be 1 month or 1 week or whatever. And if the pool is old enough, and if the time of that scrub was old enough, it will just start a scrub, and then the script will exit. So very simple thing here to do. And we know already of a similar service, which is the ZFS Auto Snapshot service. And the ZFS Auto Snapshot service is already there. We can look at how it's implemented. And I think this is it's safe to say that it's a good idea to look at those existing services, learn from them, and help ourselves there. There's no point in reinventing the wheel, and we can instead concentrate on what makes our service unique and what is different from a already existing service. So here's the quick run-through of the Service Management Facility, or SMF. It's there since Solaris 10. It manages all of the services of the system. It's a replacement for the boot mechanism. It replaces the old etc initd hierarchy of scripts. It can do much more for you. It's a nice framework for writing your own scripts, not only for starting and stopping stuff, but also for expressing dependencies. So if you run whatever service, you can tell it what it depends on, and it will be started at the right time. And it's also a great way of handling any error messages and doing automatic actions on those error messages. And the most important comments to keep in mind are SVCS, SVC-ADM, and SVC-CFG. If you look at those man pages, you know everything you need to know about SMF. Of course, there's an SMF man page as well. I should probably add it to the slides, but then it will wrap over to the next line. Well, you know. So these three commands are the most important one, and there is an overall man page called SMF. Any SMF service needs some sort of script, which is typically a start and stop script. So we need to implement this for our service. And in our special case, we also want to have a cron job that's running from cron that does all the real work. And then we need a manifest for SMF that sort of describes our service to the system. You can do a little optimization here. So the start and stop script of our service, which actually only needs to make sure that cron is set up correctly, it can be merged with the script that's run by cron. So you only have to write one script, and at the beginning of the script it just tests, have I been called with start or stop argument, or have I been called with something else? And if it's something else, it just assumes that it's running from cron, and then it does the cron thing. The SMF file, the XML file, is quite easy to use. It's basically the same. Back in the old days, you used to take an old etc initd script, and then you modified it, and that was your new script. And with SMF, it's the same. You just take an old SMF manifest, and you modify a little bit. It's just an XML file. You can modify it quite easily, and there's your new SMF file. So it's really easy to do that. You just need to modify one more file. So. This is what I essentially did. So I looked at the old, shipped ZFS Auto Snapshot service. I teared out everything I didn't need to use. I kept the cron job code, and I added my code to do the scrubbing. I also took the SMF manifest and modified it to suit my needs, and you can have a new SMF service up and running in a matter of 10-20 minutes. And there you have it. So it's really easy to do. So lesson number one for me: it's okay to borrow stuff, and I think it's also a good way to avoid errors, because just by reading other people's scripts and just by reading other people's manifests, you find ideas, you think about stuff that you wouldn't have thought before. So this is a really good thing to borrow everybody else's stuff. And one of the things I learned is, so what about security? So what happens if someone manages to hack into my script? I may not be a good programmer, so maybe I left there a backdoor without knowing, and somebody hacks into my script. So how can we protect ourselves from someone hacking into our script? And this is where role-based access control can help us here. In our case, role-based access control, I assume you more or less know what it is. So in our case, we create a new role, which we call ZFS scrub, and that role only has the ability to administer ZFS pools, so that our script is not called with the full set of privileges associated with root, but only with the privilege to administer pools, which it needs so it can start the scrub. We also allow our role here to administer itself, so that the service can deactivate itself in case it finds an error or something. And other than that, it's only able to use normal user commands and nothing more. So what this does is it restricts the sets of privileges to just the necessary set of privileges we need to do our job. And should a hacker really make it into our script, the only thing he can do is destroy the pool, which of course still would be very, very bad, but of course we have backups and everything. But a hacker would not be able to take over the system. It would, destroying the pool would be something that would be very visible, so we would instantly know we have been hacked, we can react to that. So he can't just place another backdoor or do anything hidden there, because administering ZFS pools is the only thing that our hacker could do in addition to running normal user commands. So this is something like the normal way everybody should do that. If you're installing Apache, of course you would create a new role for your Apache user, and you would restrict the privileges of that role to just the few things you need to set up your own port, and that's it. And that would be even more effective. So in addition to our SMF service, we need a new role, and then we are probably done. But then, of course, I became a little bit more ambitious, and I thought, okay, so here's the lesson. So role-based access control makes it easy to establish a least privilege model. So then I thought, how about installing our new service? So I became a little bit more ambitious. I want to use IPKG eventually. So this is what IPKG lets you do. When you create an IPKG package, you can copy files, you can activate new SMF services, which is what we want, but you cannot start any scripts. So how do you create a role and tear it down so that it only has the right privileges? And so this becomes a slight roadblock here, because we only can create a new service, we only can copy files. We may create a new user, but we cannot create a role. And the reasons for that is just to make the way to install packages easier. You have less stuff to think about, and but still we need to sort of find a workaround around this. So the workaround here is we just install a new SMF service, which has the only task of creating our role. And this is actually borrowed from the ZFS auto snapshot script, which does the same. It comes with its own role, it comes with a second SMF service that sets up that role, and we can use the same mechanism here. So our new SMF service, which is the second one, will set up the new role, and then it will just deactivate itself because its job has been done. So our shopping list becomes just a little bit longer. We create our own service, we create a second service that creates a role, and that service is very simple. It just has a start-stop script, and while starting, it creates the new role and then deactivates itself. And of course, our new SMF service needs its own manifest as well, but this again is a very simple manifest. Okay, now we can start and stop ourselves, we can do everything. So lesson number 3 is we can cheat around any limitations with IPKG by using SMF, and then using that mechanism as a kind of like a Trojan horse mechanism to run our install scripts as SMF services. So one might think, well, isn't that a bit complicated? Isn't that like sort of shooting ourselves through the back into the knee? I think the good thing about this approach is as soon as you put something into SMF, it becomes documented, it becomes manageable, it becomes transparent. The administrator knows what's happening. It can see with SVCS what you're doing, and there's no hidden magic stuff happening behind the covers. Everything is more transparent. So I think this is a nicer way of handling any post-installation tasks than just doing it during the package installation process, and maybe forgetting about things like unattended installations or remote installations on hundreds of clients, where the administrator may decide to do things slightly more different. So it may seem a little bit clumsy at the first sight, but on second thought, I think this is a nice way of making your post-installation scripting jobs more transparent to the administrator. So let's get started. But at some point we want to know when the last scrub happens. So this is the part that becomes unique in comparison to the ZFS auto snapshot. So how do we know when that last scrub happens? Of course, zpool status will tell us that. So if you if you say zpool status and the pool has been scrubbed before, you will see this part here, and it will tell you when the time of last scrub does. So this is very useful. We can parse this line out of a shell script, and then actually I'm using the GNU date to feed this one into GNU date, and then I will get a proper date to work with, like seconds after 1971. And then we know what the time is, and we can do time comparison and decide whether we scrub or not. But what happens if you're running from a laptop and you reboot a lot, the pool gets exported and imported, and after you export the pool, it just forgets about when the last scrub happened. This is bad. If you want to scrub once a month and you reboot quite often, like on a laptop, you will end up scrubbing every day, and that's too much. It just places too much load on your disk. So I opened a CR because of that. Because I think it's really a bug. The time of the last scrub is really a useful information, and it's also an information that should be kept persistent. So if you want to support me, just go look up that bug, put yourself into the interest list, and maybe we can have just enough attention on that bug so that they fix it. Because I really think this is a piece of data that should be part of the pool, it should travel with the pool, and it should make scrubbing a little bit more efficient. And well, until we wait for this bug to be integrated, what do we do? How do we keep track of our last scrubs without zpool helping us? So what do we do now? Well, you might have guessed the answer. We just add another SMF service. And this service is called ZFS Scrub Track. It, once activated, this service runs once per hour, again using cron. And it will check with the regular zpool status command whether any running scrubs are finished. And once the scrub is finished, it will record the finish time in a ZFS property in the topmost file system, and then we have a permanent record of when that last scrub happened. And if no scrubs are running, it will just deactivate itself. So the only thing we need to do to integrate our new ZFS scrub tracking service is to tell the auto scrub service to start this service and to check against zpool status and our newly introduced property before scrubbing, so that it can actually read out the date. So we check whether we have scrubbed before and whether we know about that by checking the property. If we need to scrub, we start the scrub, and we also start the tracker, and that will check every hour whether the scrub has completed. Of course, there are other ways to do this. I've been thinking about using dtrace and then let the probe fire once the scrub has stopped. But again, I opted for using another SMF service because setting up an SMF service is easy and it is transparent. Sometimes the most efficient solution is not the most easy to administer, and I would advocate here that using another SMF service is just a cleaner way of doing it, because then the administrator knows what's going on at all times, and he doesn't need to wonder, so what's that background process doing on my machine? Is it something useful or not? Where do I find the documentation about that? And probably the most useful feature of SMF is that you can place links to your documentation as part of the SMF description, and then by using SVCS-X, you can just get to the link and know what happens by looking at the documentation. By the way, zpool supports properties as well. So if you do a zpool get all, you will get a different set of properties than with the ZFS file system, but there are no user-defined properties. So I would actually have preferred storing my scrub time as a zpool property, because it actually belongs to the pool and not to an individual file system. And I ended up using the topmost file system because I wasn't able to create my own zpool property. And we can debate over a cup of coffee whether this is a bug or an RFE, or whether it's just not an issue because the topmost file system is, of course, associated with the pool at any time, and we can just use that as a workaround. So this is our shopping list. It became a little bit longer. We added another SMF service, which is the ZFS Scrub Tracking service. It comes with its own start-stop script, which is also the cron script. It's modeled very similarly to the auto scrub service, and it comes with its own manifest. And of course, we could also try to integrate this service with this and make it one huge, gigantic shell script. But right now, I decided to keep it a little bit simple and then see whether we can find other ways of making it more powerful or simpler in different terms.